Fourth concept of Unit 4, we'll be dealing with applications of exponential functions. Exponential functions. There are many applications of exponential functions. Just a few are listed below. Population growth, exponential growth decay, compound interest, and growth of investments. Okay, review the graph. An exponential equation is not a straight line, but you should already know that. It is a curve that is either always increasing or always decreasing. Here are some formulas you need to remember. Compound interest. A equals P, parentheses 1 plus R divided by N, close parentheses to the power of NT. Exponential growth, Y equals A times, parentheses 1 plus R, close parentheses to the power of T. Then exponential decay is the same formula, except now you have a subtraction sign. For the equation, Y equals A times B to the power of X when the base is greater than 1 and A is greater than 0. The equation models exponential growth. When A is greater than 0 and 0 is less than B, which is less than 1, the equation models exponential decay. And as you may know, this would be a fraction or decimal. Here's an example of exponential growth. This is Y equals 2 to the power of X. Here's an example of exponential decay. Example 1. A colony of bacteria starts out with 150 cells and triples in population every hour. Write an equation that models the number of cells Y after X hours. Graph the equation. Okay, so your first step is determine the values of A and B. Okay, so what we know is this. We are looking for Y. Y is the number of cells. And we know we're looking for X, the number of hours. So what we know is this. We start out with 150 cells. I'm going to call that A. Times 3 to the power of X. There's my equation. Now, to solve this, you're going to make an equation to make a, you're going to use the equation to make a table of values. Okay? So I'm going to go 0, 1, and stop with 2. Okay, and I'm going to plug that in. 150 times 3 to the 0 power, well, that ends up being 1, and so that equals 150. Next, 3 to the first power is 3. 150 times 3 would be 450. And then 3 to the second power is 9, and 9 times 150 is 1,350. Example number 2. Compound interest is calculated by using the formula A equals P, parentheses 1 plus R divided by N to the power of NT, where A is the accumulated amount after T years, P is the principal, the amount invested, R is the annual interest rate expressed as a decimal, and N is the number of times that interest is compounded per year. Write an equation to find the amount that is accumulated when $500 is invested with a 3% annual interest rate, compounded monthly. So, first step, identify the values of P, R, and N. P is the principal, the amount invested. In this case, it would be $500. So P is equivalent to 500 in this problem. Next, R. R is the annual interest rate expressed as a decimal. Well, interest rate is 3%, so that would be 0.03. Next, N, the number of times compounded. In this case, monthly. There are 12 months in a year, so N equals 12. Now let's write our equation. A equals 500, 1 plus 0.03 divided by 12 to the power of 12 times T, where I can plug in T, how the account grows over time, and I could go year by year by year. I could plug in 1, plug in 2, plug in 3, and follow the order of operations and solve. Example 3. A new car is bought for $10,000. Its value decreased 10% each year. Find the value of the car after 3 years. Okay, so we're going to use the formula for exponential decay, decrease, because it's decreasing each year. Identify the value of A, which is your initial value. In this case, the initial value is $10,000. 1 minus, the rate is 10% each year, and then your time is the year. And I want to know the value of the car after 3 years. Okay, so now let's try that out. 1 minus 0.10 to the power of 3 times that by 10,000, and I get y equals 7290. So after 3 years, that new car will be worth $7,290. That's how you use the formula for exponential decay or decrease. Now let's look at a different one. A home is bought for $120,000. Its value increases 5% each year. Find the value of the home after 10 years. Now that formula we're using here looks similar. The only difference is you're adding because the value's increasing. A is the initial value, so 120,000. 1 plus 5%, so 0.05, and T. And in this case, I want to know after 10 years, I'm going to plug in T. Okay, so I add those together, I get 1.05 to the power of 10, times that by 120,000, and I get the new value is 195,467. I'm going to round that to the nearest hundred, $36,000.